This lesson is on the properties of chords. Just going through the theorems here that we learned. The first theorem says that if you have the same circle or congruent circles and two minor arcs are congruent if and only if their corresponding chords are congruent. So we could say AB is congruent to CD, arc CD, if and only if AB is congruent to CD. So if you look at the first example here, what we have is that you've got the same circle, and we are told that here our arcs are 120 and 120, so they're going to be the same. What does that mean? The chords are going to be the same. If this chord is 60, what is X? X is going to represent 60 because the chords have to be the same length. Likewise, if you look here and you say, oh, there the chords are congruent, then that means that the arcs are also going to be the same length. So it says solve for X. So 2X would then equal the X plus 40. So we subtract X from both sides, and X is equal to 40. On the next example, if you look at it, these are two more theorems. The first theorem says that if you have one chord that is perpendicular bisector, so AC is obviously a perpendicular bisector because there it makes that right angle and there it bisected this one, then what can we conclude? Then we can conclude that AC is a diameter. So if you look and you say, hey, not only did it make a perpendicular line, but it bisected, then that means that this has to be a diameter. Likewise, if you look at the next theorem states that if you have a diameter of a circle that's perpendicular to a chord, what can we conclude? We can conclude that that diameter bisects this chord. So if I know for a fact that AC is a diameter and that AC is perpendicular to BD, what could I say? I can say that this BE is going to be congruent to ED, as well as their chords or their arcs are also going to be congruent. So let's look at how we could apply this. Looking at example number 3. All right, it says solve for X and Y. So if we look here, this is going to be a diameter because it goes straight through that center point and goes from both sides of the circle. So that has to be a diameter. And it's a perpendicular bisector. So what does that mean? Well, that means that X here has to be the same length. X is going to be 24 because it's been bisected, so these two are going to be congruent. What else does that mean? Well, we can figure out what Y is. This is 60 degrees for the whole arc here, and remember it's split into two halves. So 60 divided by 2 means that Y is going to be an arc of 30 degrees. Let's skip to number 5. It says, in our circle here with circle R, we're told that XY, this whole length, is 30. And we're told that RX here is 17 units, and we have been asked to find RZ. Now, if you look, we're told for a fact that RZ is perpendicular to XY. And if you also look, we've got our diameter. What does that mean? It means that our sides here, our segments are going to be bisected, or they're going to be congruent. So I can figure out what RZ is, because if I know that this entire length here is 30, and it's two equal halves, 30 divided by 2 makes this 15. Now I've got myself just a little right triangle here. So I can do A squared plus B squared equals C squared. So I'm going to say I don't know one side, but I'm going to add the leg that's 15, and I'm going to add this leg here that's 17 squared. And we can go ahead and solve for X. So we're going to do 15 squared, which would be 225. Then we need to do 17 squared, which is 289. Subtract 225 from both sides, and X squared is going to equal 64. Take the square root of both sides, and X is going to equal 8. And so what is RZ? Well, this RZ is going to be 8 units long. And then finally we come to our last theorem here. Our last theorem states that if we have the same circle or congruent circles, two chords are going to be congruent. So these chords are going to be congruent if and only if they are equidistant from the center. So we see that both of these chords are the same length away from the center. So looking at example number 7, we're told in circle A, PR is equal to 2x plus 5. And QR is equal to 3x minus 27. But if you look, both of these chords are equidistant from the center, which means they have to be congruent. which means their measures are going to equal each other. So we can set them equal to each other and solve. If I subtract 2x from both sides, I get 5 equals x minus 27. If I add 27 to both sides, I'm going to get 32 equals x, and that's all I'm asked to find is x. I don't even have to plug it back in according to the directions.